Hi everyone. So this topic will introduce you to classification, and we will talk about the basics of classification and what are the standard ways of creating a static classification model. So let's move ahead. So in classification there are predefined categories or classes. Categories or classes means that if somebody belongs to a particular category, yes or probably no, so this could be a binary category. Then you will have categories of classes like somebody is in university, somebody is a student, somebody is a teacher, somebody is an administrative worker, so that becomes another category. So in classification you have categories and classes, and you will be given a set of objects or records, and each of these records would be belonging to one of the class. Take for an example, like in your email, in your inbox, there is an automated mechanism which will land some emails in your inbox and some in your spam folder. So how does it do it? So in generally what happens is that if the people you are communicating with, they are in their address book, or you frequently exchange your emails with, they land in your inbox. Even the new emails also land in your inbox, but there are certain emails which look like spam. For example, asking for loan, giving away you prizes. So there have been some models built which can classify and tell you whether this email should land in your inbox category or in the spam category. So this is what a work of classification model is. Or probably if you have been given a data set or a record and you want to help the diagnostic team to tell that based on the size of the tumor whether the tumor is benign or malignant, then using certain properties of the tumor you can help the diagnostic team determine the malignancy or benign tumor. So how does a classification model look like? Generally you have a set of input variables. These variables you can set an attribute set, you can call them the set X, or you can call them the independent variables also. So in your records there will be certain variables that when put together and passed as an input to your classifier will give you an output, that is this set of inputs or X attributes or independent variables together form or fall into one class. So that class becomes your target variable or class variable. You can call it the Y variable or the dependent variable or the output. So given a combination of X attributes in the set X, it will be passed to a classifier model, and you will be able to correctly predict the class of that particular set. For example, if there is an email, so it must be having some properties like to, from, subject field, probably the IP address, and now using the classifier model you have to categorize whether it belongs to the inbox or to the spam category. So the from field, to field, time field, probably the subject line, all these become your set X or attribute set, which will be helping you determine the output variable or the target variable, which is your spam or inbox. Moving ahead, like for example, this is my credit risk file. So it has 13 attributes. If you can see, it's a loan ID, gender, whether the person is married, whether he or she has dependents, the education status, whether the person is self-employed, or what is the income, is there any co-applicant, so if what is the income of the co-applicant, what is the loan amount that has been requested, and what is the term in months for the loan amount, whether the person has a credit history or not, to which area the person belongs or resides, whether is in an urban setting or in a rural setting. So based on these attributes, the loan status is the category or your target variable, that whether the person was granted loan or not. So now you will be using these attributes. You may use all of the attributes, or you may drop some of them and use only the important ones that that depends on your problem statement or your business decision, what all things are important for you. And based on these set of attributes X, you will be able to classify the record whether the loan status was granted or not. So you already have some existing sets of records, and using those records you will be picking up some attributes or maybe all attributes, and you will be predicting the loan status. You will be using this a priori information to guide or train your model, so that whenever a new record comes, the model can be able to classify whether this particular record should be given, this particular person should be given the loan or not. So as I again said, that you might or might not need all of the attributes, but you should be able to identify your target variable, and it should not be included in your independent variable set or X set. So your this target variable will be in this case the loan status, and the attribute set will be the other attributes that you have used to pass through your classifier model. Now if I talk about this X, then it is an attribute set, and it can have all the attributes which can be discrete or they can be continuous also, but your prediction variable Y should always be discrete, and you call this Y as the class label. So if I want to define classification is the task of learning a target function or creating a model that will map a set of X of attributes that belong to a set X to a predefined class label Y. So if I talk about classification, so there will be X set of independent attributes which will be mapped to my target variable, which is the loan status. Now if I talk about applications of classification, so application is that classification can be descriptive in nature. It can be used to describe objects of a particular class, that how do emails in a spam folder look like, or how does a benign tumor or a malignant tumor look like, what will be the properties that will help me identify whether the tumor is benign or malignant. Then it can help me in predicting the class labels of unknown records. So I already have a lot of training data, I already have a lot of information with which I have told my classifier or my model that this is how you decide whether something is a tumor is benign or malignant, or if an email is spam or it should go to the inbox. So whenever a fresh record or a fresh occurrence comes, fresh set of attributes comes which have never been seen before, so my classification can help me predicting the class label of this unknown record. So classification is typically well suited for describing or predicting the data sets with binary or nominal attributes. So if you have binary or nominal attributes, it works well, but it is somewhat less effective if you have ordinal attributes like small, medium, large. So it is quite a bit less effective as compared to binary or nominal attributes. Why? Because here you are not rating the importance of the ordering between the categories. So because the algorithm is not taking that into account, so maybe there might be some chances of error. Another thing that it ignores is the relationships or hierarchies among different categories. Now how to build a classification model. So first thing is to identify your problem statement, identify what your target variable is, what is the prediction variable. Then you will talk about pre-processing the data by cleaning up or removing the null values, replacing the missing values, standardizing data and normalizing the data. Then you will choose classification algorithm, which I will talk about later, and then you will choose the features or attributes to train the model. As I said before, for example, in the credit risk file, if you see here, this loan ID will not have any impact on the loan status, so it's better to drop it. So this means that I don't need this attribute to play a role in my classification algorithm. So you will choose the features, then you will sample the existing data by splitting it between training and testing sets. Suppose my credit risk file had 1000 records, so I could split it between 750 and 250 records, where I would use 750 records for the training purposes and the rest of the records for testing purposes. So this ratio could be 60-40, it could be 70-30, 75-25. So it totally depends on the number of records you are having. So suppose you have millions of records, and you can take an advantage of dividing training and testing samples into 50-50 for a better results. So after sampling the data, you will train the model with your training set, and you will use the test set for which you as a programmer or as a data scientist know the class variables, but your model does not know. So using the training set, you have trained the model to help it identify what looks like a malignant tumor or a benign tumor, what looks like a spam email or a email that belongs to an inbox, or probably what kind of a person should be granted loan or should not be granted loan. So with the training set, you have trained your model. Now you have the test set. This model has not seen the test set, but you know what this test set looks like. You know the class labels, but not the model. The model does not know. So you run the model and you give it the test set, and you ask it to predict, okay, now tell me to which category these this sets belongs. So it will predict for each and every record, and then because you already know the final result, just try and compare and validate your model. So if there is a problem, then you will try to retrain the model again by maybe dropping some other attributes, or maybe adding more attributes, or maybe trying a different algorithm, and then you will just keep on building the model till you achieve the desired accuracy. So the model that you have built should have a good generalization capability. It should be able to fit the input data well, that if it is able to fit the input data well, yes, then it can generalize, but it should also be able to classify well the unseen records. So if you have a training set, you use it to train the model, decide on a learning algorithm, and build the model. So it is not necessary that within the first iteration you will get a good model. So you will have to retrain it, maybe use a different algorithm and build different models, and finally decide or pick the best one, and then use it to deduce and apply this model on your test set and see what the accuracy is. So what kind of learning algorithms should be, and how you decide on your accuracy, or how to pick up a good model, I will be talking about that in some other lectures. So that's it for classification. You can ask your questions in comments, and you can like this channel, share it with your friends, or subscribe to this channel to keep learning. Thank you, and bye for now.